I welcome you back to this online tutorial on empirical and molecular formula. We had covered the two items. Today I am starting with item 13. Item 13, hope you have your item 13 there. Mine is also as well here. Item 13. On empirical and molecular formula. Item 13 says that the gaseous hydrocarbon are a carbon-based fuel cell used in racing cars in Formula 1. Formula 1 is a racing competition. Yeah. For those of you who don't know, it is a racing competition which involves smaller cars where we have constructors like Mercedes, Red Bull, Racing Honda, who manufacture cars that are driven by different competitors. So Formula 1 is a racing competition involving different cars. So the preliminary experiment shows that the hydrocarbon R contains 82.76% carbon and rest being hydrogen. So we have R has 82.76% carbon and the rest hydrogen. So percentage of hydrogen is not given, but we have that of carbon. And we know that the total percentage is 100. So we have that of carbon, so we shall have to first find that of hydrogen. Its internal engine combustion gave out carbon dioxide, water vapor, and heat energy according to this equation. However, the manager of Formula 1 is not only interested to know the relative molecular mass, RMM of R, used in the process if 140 centimeters cubed of R weighed 0.363 grams at STP, but also the usefulness of the gaseous product produced. Now we have this information. Now when you see this additional information must help us, in most cases, it must help us find molecular mass. So if you are to determine, moreover, you are even seeing here is saying that is not only interested to know the relative molecular mass. So this information is on molecular mass, and once molecular mass is, and once we have information on molecular mass, you have to know that if they task you to determine the formula, now here we are lucky, it says that determine the empirical formula and hence molecular formula of R. But if it just says that determine the formula, if this item just specifies determine the formula, then you must determine the molecular formula because you have information on relative molecular mass. I stressed this out in the previous item and I am also re-echoing it here. Now we go to our response. We have to determine the empirical and molecular formula. What is this? A moment. Now I have done examples on empirical formula where I have showed you the steps in detail. So in this case, allow me leave those steps. So we determine the percentage of hydrogen because it is not given. We have percentage of carbon. Percentage of carbon, look at that item. Percentage of carbon is 82 point something. So if we want to determine percentage of hydrogen, we shall say total percentage, which is 100 minus that of carbon. And calculating this, we obtain 17.24% as percentage of hydrogen. So step 1 says that you write down the elements that make up the compound. So elements present here, we have elements that make up the hydrocarbon, that is hydrogen and carbon. So we have carbon and hydrogen. Then next, step 2 says that you write down the percentage composition. So composition here for carbon, it is 82.76 and that of hydrogen 17.24. Next, we determine the number of moles. How do we determine the number of moles? We have seen in item 14 and 15 that to determine the number of moles, you divide by relative atomic masses. So here, relative atomic mass of carbon has been given as 12. this information has been given in the bracket, and that of hydrogen is also 1. So we divide the composition of carbon by 12, hydrogen by 1, and computing this division, here we obtain 6.897, and here we obtain 17.24. Next, we divide, we obtain the simplest mole ratio. How do we determine the simplest mole ratio? We look at these two ratios. We look at these two ratios, then we divide by the smallest, and this is the smallest. This is the smallest. Therefore, we shall have the following. So we divide by 6.897, we divide both of them. And after dividing, in this case, we obtain the ratio as 1 to 2.4996. Now, you have to be very careful. Let me take you back to my rules. My rules, these are what my rules are saying. Some of you might have forgot. The rules are here. Steps followed in calculating empirical formula. Next, there is something which I stressed here, but I did not explain it in detail. I just said that we shall go back to it when I'm dealing with the examples. Now, this rule says that, this step says that the simplest mole ratio obtained, should be handled with care. You see, I even made it bold. It is in capital letters, and I made it bold, implying that it was very important. Now, for example, I explained this. I explained what happens if you have digits of this form. If they appear in the ratio, they are rounded off. 0.1 to 1, 0.2 to 1, 2.7, 0.7 you round off, 0.3 round off, etc. I explained this earlier on. Now, there are these figures. Now, if these figures of anything 0.33, 0.5, 0.66, 0.4, if the figures of this form, 0.something, 0.33, 0.33, 0.5, 0.66, 0.4, if such digits appear in the ratio, what do we do? What do we do if they appear? Because now this is what we have. We have 2.4996, and here it is even here 3.4.4. But here someone can also decide to round off. Someone can also decide to round off as well to 2.5, but you can as well leave it there. So it has 0.4. Now this is what the rule says: 0.33, 0.5, 0.66, 0.4. Now we are here 0.4. What do we do for 0.4? It says that if they appear in the calculated ratio, the calculated ratio should be multiplied by, so if you have 0.33, calculated ratio should be multiplied by 3. If you have 0.5, calculated ratio should be multiplied by 2. If you have 0.666, calculated ratio should be multiplied by 3. If you have 0.4, calculated ratio should be multiplied by 2. I have said, if you have digits of this form appearing in the simplest mole ratio, what do? If you have 0.33, you multiply by 3. If you have 0.5, you multiply by 2. If you have 0.66, you multiply by 3. 0.4, you multiply by 2. You multiply throughout the ratio. Now, here we are going to do that. So we shall multiply by 2 throughout. You can as well round off this to obtain 2.5. You round off here. I have not said that you round off this to obtain 3. No. I have said you round this 4. This 4 can be, because what follows, this 4 is a 9. You can round off and obtain 0.5. So this is what I have. So you multiply by 2. So 2 affects this one. It also affects here. Now, if you press your calculator very well, after multiplying 2 times this one, we obtain a 2. 2 times 2.5, you obtain 5. Therefore, our empirical formula, this is our empirical formula. So this is our empirical formula as wanted. The item also wanted the molecular formula. Molecular formula. Now we go to molecular formula. For molecular formula, there was information which was given on molecular formula. Let me take you back to my item. Now there is this information. There is this information on molecular formula. It says that, however, the sports manager of Formula One is not only interested to know the relative molecular mass, RMM of R, is not only interested in knowing RMM of R used in the process. If 140 centimeters cubed of R weighed 0.363 grams at STP. Now this information, 1.4 centimeters cubed of R, 1.4 centimeters, no, not 1.4, sorry, 140, sorry, 140 centimeters cubed of R weighed 0.363 grams. This information is going to help us determine relative molecular mass. It's going to help us determine relative molecular mass. Now I go back to the item. 140. Hope you've taken note of that information that has volume and mass. That 140 centimeters cubed weigh 0.363 grams. That information is going to help us determine a relative molecular mass. So to determine molecular formula, we say that empirical formula times N equals molar mass. But this molecular mass, we don't have it. That's why I put a question mark. That's why we have a question mark. Therefore, we determine this molecular mass. The item has said that 140 centimeters cubed. Now, I have volume. What I want must be on the right-hand side. Do not always forget that. That's why mass is going to be on the right-hand side. So the item says that 140 centimeters cubed occupy 0.363 grams of R. So this volume occupies this mass. Then what of 1? If 140 occupies 0.363, what of 1 centimeter cubed? This will occupy, we divide 0.363 over 40 grams of R. Then what of the standard? The standard, remember the standard is 1 mole. The standard is 1 mole, and 1 mole is molecular mass. What of the standard at STP? Standard I'm meaning at STP. I explained those things earlier on. If you are watching this video for the first time, there was information which I explained on the mind map. So what of the standard, which is 22,400 centimeters cubed? This will occupy, we shall have 0.363 over 140 times 22,400 grams of R. And in this case, we obtain molecular mass as 58 grams. Now, this is the first approach. First approach towards determining molecular mass. Another learner will say that, if you don't use this, another learner will say that, what have you given me? You've given me 140 centimeters cubed. And this is equal to 0.363 grams. Now, this learner will ask him or herself, if this is what is given, then what of the standard 22,400 centimeters cubed? Because this standard is the one that represents molecular mass. Yes. You may ask me, why are you now bringing the standard which was not given in the question? It was not given in the question, but it may be on the front page of the questioning paper. Yes, it may not be given directly, but this standard is the one that represents 1 mole, which is molecular mass. So what of the standard? Now we ask ourselves, the standard will contain how many grams? Now we cross multiply. We have seen such calculations already. We cross multiply, we shall have this multiplied by this up here. And now if I cross multiply, we have molar mass equals, we have 0.363 times 22,400, then divide by 140, and molecular mass will be 58. So you can use this first approach or the second approach. Now that I have molecular mass, I can substitute back and I continue with my molecular formula. So empirical formula times N equals molecular mass. So my empirical formula, this was my empirical formula times N equals molecular mass, which is 58. Then we compute, we shall have capital C carbon is 12, and there are 2 of them, plus capital H is 1, and there are 5 of them, then times N, this is equal to 58. Now summing this up, we obtain 29. We obtain 29, N equals 58. We divide both sides by 29. If we divide both sides by 29, we obtain N as 2. Therefore, our molecular formula, I will substitute back this value of N. So we have N substituted back. This 2 multiplies on carbon. It also multiplies on hydrogen. Once it multiplies on both carbon and hydrogen, we shall obtain this as our molecular formula. Allow me stop here for that session. That marks the end of item 13.